Alright, one more problem from beginning to end. If you want to pause the video and try this yourself and then see if you get it right at the end, you can certainly do that. First thing I'm going to do is list out all the possibilities. So this is the p divided by q. I want factors of 8. 1 times 8, 2 times 4. Divided by factors of 2. Okay, so our list of possibilities are, so I'm going to take 1 divided by each of these. Take 2 divided by each of these. 2 divided by 1 is 2. But 2 divided by 2 is 1, and I already have that there. So I'm not going to rewrite it. Now 4 divided by 1 is 4. 4 divided by 2 is 2, and I already have that here. Next I'm going to have 8 divided by 1. And then 8 divided by 2 is 4, and I already have that. So these are the possibilities right here. There are 10 of them. I know that there's only going to be 4. Okay? A maximum of 4, and I have 10 to choose from. So the next thing I'm going to do is I'm going to draw a graph of this function. I'm going to use the graphing calculator to do that again. So let's see, we've got 2x raised to the 4th minus 7x raised to the 3rd minus 8x squared plus 14x plus 8. And let's see what the calculator looks like. Alright, let me blow this up a little bit with a zoom box again, just like we did on the last one. I don't need to see all the graph. I don't need to see the maximums and minimums. I just need to see where it's crossing through the x-axis. Let me bring this up so we can see a little bit better here. And get the sun off of it. Alright, well it looks like the best choice to begin with is right over here at 4, because it looks like it definitely crosses at 4. The rest of these, it looks like fractional type values. I'm going to try 4, and I'm going to try this one here. If you've done this on your calculator, it's going to look to you like it does to me, that maybe that is negative 1/2. So let's try 4 and negative 1/2 and see what happens, see if we get some zeros. Okay, so we've got 2, negative 7, negative 8, 14, 8, and we're looking for a 0. We're going to try positive 4. Sure enough, it worked. Okay, so positive 4 is a 0. The other one that we were going to try is negative 1/2. So I bring down the 2, and I multiply. I add together, and I multiply. I add together, and I multiply, and sure enough, that works too. Okay. Now, I wasn't quite sure what the other ones were, because they were fractional values, they were decimal values, but they weren't half or negative 1/2. Those other ones. So what are they? Well, let's see if we can find them another way, and they're clearly not 8, 2, or 1. I mean, they were between the tick marks on the axis, so clearly the only 2 that come off this list are these 2 right here. So can we find the other 2? And the answer is we can, and here's how we can do that. Recall that this polynomial started as an x to the 4th. So when I divide this 4 out, these numbers down here begin with x to the 3rd. When I divide this negative 1/2 out, this is now x squared. So this is 2x squared minus 4. That's what's left over. I can't factor that. But I can solve it. If I set it equal to 0, solve for x squared, and then solve for x, There's our other zeros. So the reason why they weren't on the list is square root of 2 cannot be expressed as a fraction. It's not a rational zero, so it's not on the list. But it's a zero nonetheless, and we're asked to find all the zeros. We're asked to find all 4 of these zeros. So we want 1, 2, 3, 4. We've got all 4 of them now.